unit conversion questions. So this one is setting up a unit conversion in chapter 1. So what we're trying to do, all we have to do is put the units. We don't have to do anything with calculating this. But we do have to put the correct value next to our unit. So our unit, whatever unit we want to end up with over here, we have to put on the top. So that's how I do this problem. I look over here. Oh, KPA is over on the answer, so I need KPA on the top. And then so PA is on the top. I need that to cancel, so I put it on the bottom. So that's how I think through that. So PA on the top would cancel with a PA on the bottom. And then I just have to make sure that I have something that's equivalent. So something on the top that's equal to something on the bottom. So KPA is telling me that I have 1,000 pascals. So on the bottom, I need this to say 1,000 pascals. That's my first conversion. And then the next one, this one's a little bit trickier because it's cubed, so we have to watch out for that. So over here, I need meters cubed. So I'm going to get my fraction. So whatever unit I end up with needs to go on the top of my fraction. And then whatever one I want to cancel out goes on the bottom. So this one's on the top. I need to cancel it with centimeters cubed so that I'm getting my unit in there. And then I need to go back and make sure that it's equivalent. So right now, centimeters and meters cubed are not equivalent. So for every 1 meter, I have 100 centimeters. But it's not just 1 meter, it's meters cubed. So if I cube this, then I need to cube this also. So I'm going to raise this to the 3. And sometimes Alex is a little bit particular about how they like us to put this one in. So let's see if this is right, and we'll see how it wants it typed in. Okay, and that works out. Okay, so that will work. So I'm just trying to cancel out the units. So let's try another one of these. Let's see, so this one I'm going to do the same way. So I have, there we go. I have kilojoules on the top at the end, so I need to end up with that. So I'm going to put that on the top, and then I need to cancel out joules, so joules is going to go on the bottom. And then this is saying 1,000, so K is like 1,000. So this is 1,000 joules on the top. That prefix is 1,000. So then I need 1,000 joules on the bottom. So 1,000 joules for 1 kilojoule. And then this one's a little different because it's on the bottom. So whatever I end up with in the answer needs to show up in my conversion factor in the same place. So moles is on the bottom, so I'm going to put moles on the bottom here. And then I need to cancel out millimoles, so I'm going to put millimoles on the top. And millimoles is a small unit. So this is 1,000 times smaller than a mole. So I'm going to put 1,000 millimoles for 1 mole. And then this should work out. So millimoles will cancel, joules will cancel, and we'll get kilojoules per mole. And then we didn't have to do anything with degrees Celsius. That just came along. Okay. If you can't remember how many millimoles are in a mole or how many kilojoules are in a joule, how many joules for a kilojoule, you can go to this data tab. So you'll get the calculator on the test, you'll get the data on the test, and you'll get the periodic table on the test. So those are things that you can use. This is also handy. Some of these topics have a video. You can watch somebody else explain this topic to you. So let's go to the data and just look really quick. Oh, it looks different this year. So what we want is SI prefixes. So if we click on that, and that makes it pop up right there. And we can see, we have kilo. So kilo means times 10 to the 3. So that's what I've done, times 10 to the 3, or I've done 1,000. And if you do that on your Alex calculator, let's look at that. Or milli is times 10 to the minus 3. So let's see. Let's try this one. If I do in my calculator 10 to the, where's my to the 3 that's the same as 1,000. And I can go back and forth between scientific and, I guess, decimal notation, regular notation. So that's kind of a easy way. And you will get this data on the test, so you don't have to remember all those SI prefixes, unless you have a better way for yourself to remember these prefixes. Okay, and I also want to talk about this topic, the multiplication and division of measurements. So this question asks, is this possible? For this class, I haven't seen one that's no. So always just click yes. Yes, these are all possible. And then we just have to make sure we do the math right and carry the unit through correctly. So this is 7 times 9. Maybe you can do that in your head. Okay. So that's 63. And then we have 2 sig figs here and 2 sig figs here. So my n number needs to have 2 sig figs. And then Alex is really particular about you putting a decimal at the end. So I can see that's 2, but Alex wants you to put the decimal. So be careful about that. And then we're not done. We need to put the units. So this has kilograms squared. And then we have another kilogram. So that's 3 kilograms. Kilograms cubed. Okay, so that one's done. This next one says 8 deciliters squared divided by 0.4 liters. These are both volumes. So we need to make sure that it ends up in the same unit. And deciliters is a weird one. We don't really use that one. So what I'm going to do is I'm going to go to my Alex data, look at my SI prefixes, and figure out what deci means. So deci means times 10 to the minus 1. So I'm going to convert this liters because it doesn't have a squared. I'm going to pick the one that's not squared or cubed. This one is, I need to convert liters to deciliters. So I'm going to say, let me pull up my whiteboard. If I have, so I have this, I have 8 deciliters squared over 0.4 liters. I'm going to convert this to deciliters. So to do that, I can think about this. So deciliters is times 10 to the minus 2. What does it say? 2 or 1? Minus 1. So I just need to move the decimal on the liters 1, and then I need to move it the right way. So liters is bigger than deciliters, so I'm going to have more deciliters to represent the same number of liters. So this is 4 deciliters now. 4 deciliters gives us 0.4 liters. That makes sense. 8 deciliters on the top. So I'm going to do 8 divided by 4. That one is 2. And then if I look at my units, I have 2 deciliters on the top, 1 on the bottom. So 1 on the bottom will cancel with 1 on the top, and we'll just have deciliters. So 2 deciliters, and then we need to look at our sig figs. Both of these have 2 significant digits, 1, 2. The 0, leading 0 doesn't count. 1, 2. So both of these have 2. So our answer needs to have 2 sig figs. And then I need to put my unit, deciliters. Then this one we have a mass and a volume, centimeters cubed. So this one, all we have to do is just do the math. 6 divided by 2 is 3. They both have 2 significant digits. So 6 divided by 2 is 3. And then we have 3.0 to get 2 significant figures. And then our unit is grams per centimeter cubed. So we only have to convert the units to match if they're both the same thing. So this is a volume, this is a volume. They need to both be the same unit. Okay, let's make sure we're doing it right. Okay, and we'll stop there.